depaneling systems at LPKF. We are also covering, of course, other technologies, also some other applications which might be interesting for you. So in case you have any interest in laser welding or also other stuff, also keep us in mind. We're doing a lot of stuff with lasers, maybe starting also with some words about the company itself. So we are located in Garbsen, quite close to Hannover, because Garbsen is not even telling a lot to someone in Germany, so we also add Hannover because it's really close by. In the northwest of Germany we have about 700 employees. At this location about 400, so we have also some other locations around Germany and also worldwide. And what we're mainly doing is that we are a mechanical engineering and also a technology company. What does it mean exactly? So we are developing technologies and also are introducing them into the market by developing new machines. A good example are the laser systems which we're offering, for example laser depaneling and also the stencil laser systems. So most of the stencil which you are using maybe on site are cut by a LPKF stencil laser machine. So in that case, and also regarding laser depaneling, we are a market leader because we're in the field for a couple of years. Also gained a lot of know-how. We know how to use the laser and how also to deal with problems which might occur by using laser. And of course, we are also always introducing the newest developments which we have. I will also introduce one of the new innovations which we have later to you. And yes, to do that, of course, we need to reinvest quite a lot in the development department. So about roughly 10% of the turnover always goes directly back into the development department. So what are we covering today? I would like to present to you some of the technological advantages the technology is offering. Of course, depends on the application how much you can use it for you. So there are some differences, but in general there's a lot of potential which you could use. And afterwards I would like to present just with a couple of words the system portfolio, so you have a brief idea of what kind of machine solutions we are offering. And last but not least, I would like to introduce to you to one of our unique system features, which you will also not find for one of our competitors. So it's developed and also manufactured by ourselves, so it's quite hard to copy it. Yeah, let's start with the process itself, because to better understand also the advantages, it's very important that you know how the laser process works, because maybe some of you are more familiar with traditional or with the mechanical separation methods. I would just like to introduce it to you. So what we are mainly doing is that we are cutting with the laser in a scan field. So it's a rectangular field, for example 80 millimeter in one and 80 millimeter in the other direction. And in this scan field we are cutting the information which we have given the system in the data preparation. So you would integrate your Gerber files, then you would have a look if you have a full cut or maybe have a tab cut, then you would choose some cutting lines, and these cutting lines are afterwards cut. And what we do is that we remove the material layer by layer, so it's always a very thin layer, but it's pretty fast. So you always go over the contour layer by layer, maybe roughly 50 to 20 micrometer with each interaction, and thereby you can remove it quite accurate. And you also have, of course, some other opportunities which I will also introduce to you later. So you cannot just cut the material, you can also do engravings and a lot of other things. So yeah, it's a very flexible tool in the end. What is one of the main advantages and what is also a central trend over the last years is here I brought along a diagram which shows the price-performance ratio and how it developed within the last decade. So about 10 years ago, and that's also what I hear from some customers when they started to have a look on the technology. The systems have been a bit more expensive, the laser sources have not been so powerful, but this has changed a lot during the last decades. So we have two central trends. One is also still applying, though we of course seen inflation now, but the trend that we have more performance per price is still increasing, so you get more watts, so more laser power for the same price, and this trend is still going on. On the other side, this of course that you have more laser power, not just 5 or maybe 10 watts, but 27, 50 or even 60 watts, it helps to increase the performance because it has a nearly linear correlation between the laser power which you have and also the performance which you can gain out of it. And the consequences, of course, that the technology gets more and more economical and also for wider range of applications. So it started with maybe some flex applications. We have a lot of systems, for example, in China and in Asia, but for now we also see that rigid applications, FR4 applications, up to 1.6 or even 2 millimeters, we can easily also compete with traditional milling technologies. So you don't need just to consider it for some special applications, but you can also consider it for, I would say, standard applications which you have maybe in your product portfolio. What is also one of the main advantages which we have is the outstanding precision and quality. If you compare the accuracy of the systems, in terms of the laser systems, we are in a range of 20 to 25 micrometers. In case of a milling system, it's in most cases roughly about 100 micrometers, so it's a factor of 4 or 5, which you can boost your accuracy. That also gives you much more potential. Also, when you have a look on IC packages, for example, where you need quite a good accuracy, this is also possible with a laser system. Then we have, of course, the cutting quality. We also brought along some materials, some sample material for you, so you can have a look on what kind of cutting quality we can achieve with laser systems. So you don't need to have carbonization when you're cutting with full power, and also not having, not considering the material itself. Of course, you can cause some carbonization, but when you are using technologies like clean cut, which we offer, when you're using the tensor technology, which I will later introduce to you, it's possible to avoid this carbonization, and thereby you can have a really clean cutting edge. So it's really impressive what kind of quality you can achieve yet, and in case you're interested, you can have a look later, and it's also sometimes hardly possible to say what kind of cutting edge is cut it with a clean cut and what is not, because it's quite close by. What is of course also caused by the process, and which is mainly due to the process itself, is that we have an ablation and evaporation of the material, so we have a really closed edge. You might note from milling technology that you have some kind of fringe formation on the edge. So we do not have that, because we're kind of melting the material away and we're clothing the edge again after it's finished. So this is also an effect which you won't see with a laser system. Then we have, of course, the stress-free processing. I guess it's the first thing which is coming to mind when we are thinking about laser technology. It's also one of the main issues you have with traditional technologies, like with milling systems, for example. Of course, we are a non-contact separation method, so there's not a physical contact between the tool, so the laser, and the panel or the PCB in the end. So it's very sensitive to the substrate. What we're doing, we have a bundle of energy, and with this we are cutting through the material. Yes, the consequence, of course, is that we do not have this kind of stress And the big advantage is, of course, this is nothing you need to worry about, because you won't have the risk of your PCB getting damaged, or also components on top, by integrating this mechanical stress into the material or into the PCB. What is also another disadvantage maybe of milling your PCB is that you're generating quite a lot of dust. Of course, the laser process itself is also generating some kind of very light dust or gas, but we have a very powerful exhaust unit, and because the particles are much smaller than with milling technologies, we can also easily just get them out of the system and exhaust them, and what comes out of the exhaust unit in the end is just clean air. And of course, this also has the big advantage that you do not have the risk that there are some particles on top of the components which might cause that the circuit board in the end won't work. So it's another risk that you can avoid, and another big benefit of the technology. Here you can see how such a cutting edge of a laser cutted PCB can look like. So this is what we did with a clean cut. It should be a 1.6mm FR4 PCB. In that case, you can see that there are no residues like the carbonization on the cutting edge. Of course, you also need to consider that the process is a bit slower than if you cut it with a fast cut, so with full laser power. So you need to consider a bit more time within the process to achieve this kind of technical cleanliness. But of course, there are applications in automotive sector, or especially in medical technology, where you can take this time to be sure, or to be 100% sure that this PCB is 100% working, and that you have no unnecessary risks that there might be any influence on the PCB itself in the end. So also a big advantage is you don't need post-processing, so the cutting edge is clean. It doesn't need to be cleaned afterwards as well, so you can just integrate it in the next step and just maybe mount it in a fully automated production line, for example. Here's another big advantage is the material flexibility. In case of milling systems, or also a saw maybe, you might need to change the tool which you're using, so you might have a need for a different router bite, for example. You don't need that for the laser tool. So what we would do, we have always a consultation, or we consult you what kind of laser source you should use. You will see afterwards we are offering a couple of different laser sources which also are suitable for different mixes of application. Here we have, for example, a green laser system which is especially suitable for FR4 applications and ceramics. When you want to have a more universal tool, more flexible tool, you would go into the direction of UV laser, for example, if you have a really wide mix of application. And you just need to set up the parameters for the laser tool once, and then you can automatically use them by scanning a barcode. So you do the work once, and then you just can change the different applications in your factory without any need for a tool change or something similar. So just once preparing the software, and then everything is automated. Yes, going from also the material flexibility to the processing flexibility. This is of course due to what we have seen before, so how the process works. Of course, we do not need to cut fully through. We also do not need to cut lines, or also the contour. We can also integrate drillings. For example, in the material we can do different kinds of engravings, also very small coats on top of the material. So what limits us is here just the diameter of the laser beam. We have about 20 micrometer diameter, and this is just a limitation for us to maybe even make your codes even smaller on the PCBs. Yes, and another big advantage, we also have the panel on the right side here, is of course that you can save a lot of your material, because the cutting lines or the channel widths of the cutting itself, they are much slower when you're using the laser, because we just need about maybe 100 to 200 micrometers when we are cutting through the material. It depends a bit on how thick the material is, because then the channel needs to be a bit wider when we have thicker material. But you can say 200 micrometers should be enough. And in that case, we have 2 millimeters pre-routing on the left side. On the right side, we have just 200 microns, and we can see that we can save a lot of material by just avoiding these pre-routed tabs around and just having a full cut by the laser. So when you just have a full cut, you can really save a lot of material, and this is even more when you have smaller PCBs. So when you have really small applications and a lot of PCBs on one panel, you can save even more material and use this, of course, for on the one side you can minimize your panel size, or you can just put more PCBs on each panel, and it saves you a lot of money, because the material you would otherwise just have as, you need to remove the rest, so everything would be milled away, or also would be pre-milled and then thrown away. So it's just another way to save costs for you, to save the material, because also this will get more expensive, because we need to be more careful with the resources which we have, of course, and it helps to be even more effective in the end. So in that case, 30%, but we also had applications, quite small ones, integrated in the consumer industry that have been several 100%, because you could just put so much more PCBs on one panel, because when you have 2 millimeter on the one side, 2 millimeter on the other side, when you have really small components, it's nearly the size of the PCB itself, and you can save quite a lot in the end. Now, having a short look on the system portfolio, just to introduce you to the main facts. So there are a couple of more informations on here, but I would just like to highlight the most important facts here. So we have 2 different platforms for our depaneling systems. One is the 2000, one is the 3000 series. They can be mainly differentiated by the working area. So with the cutting master 2000, especially for the CI systems, we have 300 in the one and 250 in the other direction. For the 3000 systems, 460 and 305. So it offers a much larger working area, but to be honest, most of the applications which we see, and also most of the customer, are fully happy with the 2000 system, because it can cover most of the applications you might face. Then we have a small difference in regard to the accuracy of the system. So the 3000 system has a granite basis, and it makes the system more accurate in the end. So in that case, we have 20 instead of 25 micrometer. And as I mentioned before, the laser beam depends a bit on the laser source which is integrated, but it's roughly about 20 micrometers. So this is also what limits you in regard to maybe your designs of codes, and also that has of course an influence on the cutting channel which you have in the end. What is also important to mention is that we are delivering all our systems with the software Circuit Pro. So you use the software to do the data preparation, but it's also on the system for the processing itself, so you have an all-in-one solution, and you can also do the preparation offline and operating the system at the same time, so this is no problem at all. What we also offer are different traceability options just to further improve the software to more automated. So this is optionally on top of the Circuit Pro solution. And what is here is the clean cut technology. So the clean cut technology enables you to have a very, very good technical cleanliness in the end. And it's available for nearly all systems, just the Cutting Master 2000 systems with 2 less laser power are not really suitable because the process gets too slow. So that is why we recommend it not for all 2000 systems, but for most of the systems it's suitable and it helps you to improve your quality in total. Here a brief overview of what kind of system variants we offer. You can see we offer different power levels. So of course we do not need for every application maximum laser power. There are also a lot of applications, especially when we have FPCBs, where we do not need that much power. And for that we of course offer a more pricey system variant in the end. Then we have UV and green laser sources, because depending on the mix you might need a different wavelength. And we also have, it's not mentioned here but I can add it, we have nano and picosecond laser sources, so also the pulse durations are different, because for sometimes more demanding materials you might need a picosecond laser source because it's more sensitive. You have less time where you heat up the material in the end. So this is also the point which we might to consider when we're having a look on your applications. And now coming to the unique system feature which I promised to you in the beginning. So I would like to introduce to you the tensor technology. What is the tensor technology? Here it's a system, or it's a guidance system which we're integrating behind the scanner system. So it's not that we do not have a scanner system at all in the system anymore, but we're using it in combination with it, so we can even guide the beam even faster, so we can have a much faster guidance on the substrate itself, and this of course helps to not heat the material up too much, because the key for the laser process is that we do not heat up the material too much, because that is what causes carbonization in the end. If we exceed a different level of temperature of the material, you will see that it starts to have some carbonization, and if we are able to stay below this limit, then in the end we can have a really good and a really clean cutting edge. Yes, the first implementation was done in the Cutting Master 2240. This is also the system which we are having here, so which you can see here. We are also working on implementing it in the 3000 system platform, so this is what comes next. So we will have a few more implementations quite soon. Yeah, what the tensor in the end does is of course a targeted distribution of the pulses, so it's not in a chaotic way, it's in a planned and targeted manner. As I mentioned, to a larger area, and thereby the material at a local spot doesn't heat up too much, and the speed of the laser on the material is increased by a factor of 4, which also helps of course in the end. Now we can see the process, how it works also in comparison to normal standard processing with the laser. We can of course make it much faster, and this in the end helps to reduce the cycle times, because especially when we are or want to achieve more clean cuts, you need to have some delays, which means that you have one iteration of cutting and then you wait a couple of times so the material can cool down. It's just some parts of a second, but in the end, when you do it multiple times, of course, this has a big influence. And by that, you can decrease your cycle times by up to 70%, especially when you want to have the clean cut, when you do not have that much cutting information in the scan field. The technology helps a lot. And even when you do not just consider a fast and a clean cut, which are like the two extremes which you have, also when you're somewhere in between, the tensor technology helps a lot to reduce the cycle times for you to achieve a certain quality. So it really helps a lot to increase your productivity, to increase cycle times or to improve cycle times, and also the quality in the end. So it makes the system much more, or gives the system much more performant in the end. Yes, that was all from my side now. I would like to thank you for your attention, for having the chance to speak here to you. And in case of any further questions, just visit us in our booth. In case you have some interesting applications, just come to us, talk to us, and also if you have some ideas maybe which come to mind what you could do with the laser system on your side, just feel free to ask us, because there are plenty of possibilities what you can do with the laser system. We have a lot of customers doing some quite crazy stuff with laser systems, and just feel free to come to us, and we're happy to help you, of course.
Okay, Patrick, thank you very much.